For yesterday and today, from continuing from yesterday, this series of problems we are looking at is we take a whole and then we cut out parts of it. Over here, we are looking at this one. You have the square, cut out the circular parts. Then this one also, the square, cut out the circular parts. Okay? Now, you notice that over the side yesterday we stopped at writing the notes for pi, for diameter. You realize that this semicircle and these two quarter circles are related because they share the same radius and diameter. Now let's take a look at these questions in front. Now, right at the start of today's lesson, I want to emphasize the skill of note-taking. Let's look at page 191, this particular question. Question 2. It says the figure is made out of 3 semicircles. Find the area of the shaded part. Take pi is 3.14. Okay, I'll write my rays at the side. This one is area. So the units will be cm square or square centimeter. Okay, so it has the, because it's talking about area, so we are looking at the square centimeter. This is only area. Then let's take a look at the notes that we will write. Previously we wrote pi. Pi is, in this question,
3.14.
Okay, 3.14. Now, then we talk about writing D and R. But here's a problem. I'll give you an example. Then I write another D and R. I remember introducing to you this, what I call, this is called a superscript. When you type in a Microsoft Word, let me show you. Wait. Okay. When I type on a document or PowerPoint or Google document or Google PowerPoint, it will give rise to the same Okay, for example, let me increase the font size so you can see. Let's put it as 980. Okay, so for example, if I type centimeter, okay, I type centimeter 2, like this. Okay, then this has to be, I said, at the top. So I will do a font here, okay, and here's what you call a superscript. That means the number become on top here. Okay? So let's say for example I talk about volume. Meter cube, correct? Meter cube. But I will not write 3 as 3, right? I write 3 as tiny. So you press this button, is called a superscript. Then the cube becomes small at the top. Right? Then I remember last year when I teach you volume, I don't know whether you remember or not, but when I teach you volume, I wrote what are these three? Length, width, height. Very good. The length of the tank, the width of the tank, the height of the tank. Then after that, I wrote, for example, I wrote these numbers. Then I put it as a tiny number. You call a subscript. That means if instead of the cube at the top, it becomes a number that is at the bottom. A subscript. What is it supposed to be? Last year we learned volume. I share with you this. T. Huh? The height of the water. And then we talk about the height of the tank, right? Remember? Then tank I will use T. Remember? Okay. So we talk about the height of the tank and then the height of the water are two different things, correct? Yes. So I come back to my work here. I wrote in this 2D, DD and RB, DS and RS. Why do you think so? Yes, Zoya. Okay, look at the question. The question says the figure is made out of 3 semicircles, and then I got D for diameter, R for radius. Okay, then D for diameter, R for radius. I have two sets of measurement. Why? Very good, perfect. Okay, Shang Chen says this, because B stands for big semicircle, S stands for small semicircle. Does it make sense to you? Let's ask Elena. For the big semicircle, what is the diameter? Taisha, have you passed the mic down? You did, Elena, what is the big semicircle's diameter? 48 centimeter. Very good. Okay, then Marianne, what is the big semicircle's radius?
24.
24. Okay, 48 divided by 2, 24 centimeter. Okay, moving on. Tashin, what is the diameter of the small semicircle?
24.
24 centimeter. What is the radius of the small semicircle?
12.
12 centimeter. Does this make sense to you? Now, I have been emphasizing on writing notes since last year for you to pay attention to what measurements you are going to use. Okay, I have to solve the area of the shaded part. Question. In this question, the shaded part is here. So earlier on we were talking about the strategy of use the whole minus take away the parts. So what am I minusing here?
Small semicircle.
Okay, from where?
From the shaded part. From the large semicircle.
Okay, so from the big semicircle, basically we have to do two things. First, find the area of the big semicircle. Which, Daniel, the formula and the measurement will be half times, sorry? Can you refer to a formula sheet, please? Daniel says half times 2 pi r square, is it correct? This shows a confusion already. What is 2 pi r? Circumference. What is pi r square? Area. Daniel just came up with a new formula. It's pi r square. Okay, not 2 pi r square. 2 pi r square is a new dimension in another universe. 2 is, okay, so the measurements will be half times 3.14 times 24 times 24. Okay, so that's the big semicircle. Okay, then I need the area of the two small semicircles. Okay, there is 2 of the semicircle. For each semicircle is also half times pi r squared. Looking at this, it also cancel out each other. 2 of the semicircle, put these 2 together, means there is 1 circle. But for this one, what shall be the measurement? Cheryl? Sorry? 3.14 times times 12 times 12. Thank you. Can you see how important my note taking is? I remind myself, if I'm dealing with a big semicircle, the radius measurement is this one. If I'm dealing with a small semicircle, the radius I'm dealing with is this one here. So this is a habit that I wish that you can really build in yourself. Can? Okay, so I will solve this with my calculator. Let's ask Ryan, what will be the last step? Huh? Think first. Yes, okay. Who's ready to say that? Okay. Oh, can you explain what is that step for? What is the step? I have no numbers here. So the final step is, sorry? Sorry? Yeah, Kershin, can you pass the microphone down, please? Yes, Angel, you were saying? The final step will be, take the big semicircle. Yes, okay. So basically the final part will be, I have the shaded area. That will be the first measurement, which is the big semicircle, minus the second measurement, which is what Skylar was saying actually. He got the measurements. But I don't have it here. You fill the blanks yourself. Is that okay? Now, I really emphasize, this whole question, the most important part is here. Not the solution. I'm not that keen on you writing the solution. The solution is in the book already. The solution is what Ryan said, I can copy this. But the notes is something that you have to derive yourself. Okay? Can you understand? Imagine you use all the wrong numbers. You may have the correct working step, but you score a 0. Because you identified the wrong diameter, the wrong radius. Do you understand what I'm talking about? Okay, I cannot emphasize this enough. Please have the habit of note taking. Okay, done? Alright? Okay, so back to this question, I ask the same question again. Here, also got one semicircle and then 2 other shapes called quarter circle. But then you notice that I just write one D and one R. How come for this one I don't need to write another D, another R? Huh? Thank you, because they are from the same circle, the same size. Is that okay? Can everybody? Okay, now we move on to a new category of questions. So far we have been talking about taking a whole and cutting out parts. Then what are these ones? Thank you very much, Jeremy. Basically, for these ones, you are taking different shapes, so different parts of a circle, this one different parts of a circle, and then putting them together. And then this one is you're taking various shapes, two different shapes, and then putting them together. Just now you are cutting, now you are... You're what? Yeah, making everything together. You're pasting them together. Can you understand that? Okay, so let's go to the easiest one, which is here. Easiest but to some difficult. You know why? Yesterday, many of us struggle with recalling the formula of triangles. Now this one is easiest but also the most difficult. Why do I say easiest? Because there are only two shapes. And these two shapes, they are not overlapping, neither are they cutting into each other. Obviously, when you compare to a shape like this, definitely this is more complicated, right? You see a square that's rotated, and you see another circle and then another circle. It's definitely more complex. However, it is difficult because some of us may have trouble recalling the formulas for triangle, and even a greater struggle, forgot what isosceles means. Same what? Same size, yes. Kasha, you want to say something? Okay. Okay, you can say with your hands also. This makes it also. Same size. Okay. So again, we have two parts to it, find area and perimeter. I'm going to draw a line and demarcate my space. So before we continue, maybe you ask our class, who prefers finding perimeter? Perimeter is easier. Who thinks area is easier? Who thinks both is great for me? Okay, okay. Okay, let's give it a go. So since most of us say area easy, let's go with area first, shall we? Okay, we do area first. I'm going to write area, B for area here. And what would be the units in the end? cm squared. What is pi? What is the pi in this question? Yes, it's not a calculator question. Good point. So what is pi? No, look at the question. Yeah, just use pi is pi. So leave your answer in terms of pi. Do I need to put a number into pi? No. So this is like algebra. Pi is just pi. Okay, let's look at the semicircle here first. What's the diameter? Or what's the radius? Hey, where's my microphone now? Anaki, come. What is the diameter and radius of this semicircle? Which one? Are you talking about diameter or radius? 4? This measurement 4, is this radius or diameter?
Radius.
Why?
It's a half of a circle.
Is it the half of a circle? The half of a circle is diameter, eh? It's half of the semicircle to be exact, okay? So you can see that it's almost like a quarter circle on this A in this point. So I can say that if this is a semicircle and its radius is 4, where else can I write 4? Very good. Yeah, of the triangle. So here is also 4, and here is also 4. So the diameter of this semicircle will be 8 centimeter. Okay, let's talk about the area first since we are more akin to areas. The figure is made up of two things. I have the area of the triangle, and then we also have the area of the semicircle. Let's deal with the area of the semicircle. The formula is very good, half times pi r squared. In this case, half is half, pi is pi, r is 4 times 4. So the answer will be
16 pi.
8 pi. 8 pi and the unit is centimeter square. Okay, so we got a semicircle done. Let's look at the triangle. For the triangle, the base of the triangle is the base of the triangle is where it's sitting on, is here. Okay? Now where's the height? Height is here, right? Oh no! Oh yes, you are right. I can't use 8. Yeah, but because the height is not so easy to find. I have a right angle there, but it's difficult to find that. So I won't use base as 8 then. I'll use what Achilles said as 4. Why? Yeah, that's right. I will cut this and into 2 right angle triangle. Okay, the base will be 4, like Achilles said. So this is 4 centimeter. What's the height? 3. Very good. Because it says right angle, it must be half times base times height. So I must find the corresponding base and height. In this case is here, but very hard because the right angle is in the middle. So I will chop it up into 2 right angle triangles. Is that okay? And then I find half times base times height, so means it's 1. There will be half times 4 times 3. Which is 6. Now, this is only one side. I need 2 of these. So the area of the isosceles triangle will be 2 times 6, which is 12. So the area of the whole figure will be 12 plus 8 pi. So how is this question made difficult. It's made difficult by the triangle. Otherwise, the semicircle part. The semicircle part is pretty easy, right? Half times pi r square, then 8 pi. Finish. And the triangle, that one is the hard one. Because it's an isosceles triangle, I need to find half times base times height. So the way out is to chop it into two right angle triangles, like what Akhilesh highlighted. Then after that, I combine them, 12 plus 8 pi square centimeter. Finish. Okay, Ken? Shall I move on to the perimeter portion? Okay? Okay, let's go to the perimeter. Here the perimeter, the unit of measurement should be centimeter. Okay, to help me with recap perimeter, I will be looking for the outline of this shape. That I highlighted in green. Can I say that the perimeter will be made up of a line, and an arc? Is that okay? Is that okay? Okay. What is this line measurement? 5 centimeter. What is this line centimeter? 5 centimeter. What about this one? Need to find, yeah, how to find? Half times pi times 8. Why 8? Because that's the diameter. Okay, very good. Pi d, yeah? Pi d. Half times pi d. Okay, very good. Alright, can continue? Okay, what's half times 8? 4. Okay, so I have 10 plus 4 pi. Is that okay? Finish. The end. Right. Hey guys, do you realize the perimeter is a lot shorter steps now? Who insists the area was easier just now? Look at the perimeter. Easier what? Yeah, because but you did area first, but you look at it, you thought the area was easy. Was area really easy? It was quite challenging to do with the area, right? Correct? Because of the triangle, area of the triangle formula. You really need to remember this. But in terms of perimeter here, was it that challenging? Okay lah, correct not? I think the challenging part is that you really know which lines are you adding up. Okay, finish? Okay. Now, my question is, Brian, you said, I can copy finish already. So, next week, I give you the exact same question. Can you solve it? Maybe. That's a good start. That's a good start. Okay? Who thinks maybe? Who thinks, yes, for sure? Okay. Who's not confident? Maybe not. Outside. Okay, very good. Skylar says, where do I place the unit of measurement? Can you look at this again? I put the bracket, I put 12 plus 8 pi, that's an algebraic expression. Then I put the unit of measurement outside. Okay? Same as this one, I put the algebraic expression inside the brackets, 10 plus 4 pi, then use the unit of measurement outside. Okay, now that you have these answers, I urge you to go back and look at it again And next week, you know what? When we do this, you can refer. Okay? So do you feel a bit more confident now? We try, Next week we try to do this question for revision after the term review. Okay? And then you can refer and see whether you are able to solve it. Okay, without help. Can. Now, let's see if any of these next two questions are easier. Let's take a vote. Who say do question 2 first? Who say do question 3 first? First or second now? Which one first? Okay, who say do 3 first? Who say do 2 first? And then the rest is what? Not sure. 4 already finished already, my dear. From the because 4 finished already. Yeah. We are only left with a few more questions. Okay, guys? Let's persevere. How about this? I keep quiet and you do. You choose how you choose 1 and 2 now. Either 2 or 3. Okay? Can? I will pause. Okay. Right. This is question 2. Anybody was working on question 2? Got this okay? Okay. The area here, when I reached these steps, I found that the equation is too long. So I decided to speed it up to finding the area of the parts individually. Then after that, combine them. Yeah, so this part was a bit too long, so I decided to redo it. So I find the area of the circle. That is when I put the 2 quarter circles together with the semicircle, and I put them together, plus the rectangle, and then add it up. Okay, so that's question 2. Question 3. Question 3. Are you able to understand what I mean by I draw a line here, then I write 5 arcs, then draw another line? Then you notice that when I'm doing this shape, what I did is I tick and check. I tick and I check. So similarly for the circumference, I also find the circle. So likewise this one, when I'm making the measurements, I tick and I check. See whether you make sure you add up all the measurements and not miss out anything. Okay? Then finally, the area, 5 quarter circles. Sorry? Yeah. I will upload this. You can be able to see this after school. Okay? 8 times 8 times 1 quarter. Which one? The parameter? Okay, so this is a recording, so you can go back and pause the video and look at it again. But I urge you to try to understand first, rather than you copy. And then really it's not going to help you if you have to do the question by yourself. And there's no one to refer to. So understand the working first. Okay? Right. Okay, with that we are almost finishing with the chapter. Please catch on all the questions that you haven't solved. Tomorrow we'll deal with some of the harder ones and a bit of activity, then we are done.